Hello everyone, this is Sajid and I welcome you all to my channel Creative Tutorials with a very big heart. Before we jump on our actual topic, let's begin our day with one small funny joke. A teacher asked in a class to one student, "Why are you late?" The student replied, "Ma'am, because of the signboard." Teacher asked, "What sign? Which signboard?" Student said, "The one that says, 'School ahead, go slow.'" Okay, so that was a funny joke. So because of that signboard which you see on roads, and those are for vehicles basically that drive cautiously and go slow because there are schools ahead. Okay, this boy also followed that signboard, but he was a naughty boy. Chalo, with that funny joke, let's begin with our today's day. We are on page number 2 of a textbook. Let's learn one part and then first solve example. Okay, so what explanatory part there is, we know that for any pair of numbers on a number line, the number to the left is smaller than the other. Also, if the numerator and the denominator of a rational number a upon b is multiplied by any non-zero, that is k is not equal to 0, then the value of the rational number does not change. It remains the same. That is, a upon b is equal to ka upon kb, where k is not equal to 0. K is a non-zero number. So let us understand what's written here. This part. For any pair of numbers on a number line, the number to the left is smaller than the other. Correct now? For example, if I draw a number line for you like this, and suppose here we have 0. Okay, so here we have 1, 2, 3 and so on. And here we have -1, -2, -3 and so on. Correct now? This we have already seen in our practice set 1.1. Okay, so the sentence says that for any pair of numbers on a number line, the number to the left is smaller than the other. Suppose if I check this number, 3. So the number to the left is 2 and 2 is smaller than 3. Right? That is this true. If I check this number, 2, the number towards the left of 2 is 1, which is eventually smaller than 2. Same thing goes here as well. When we come on the left hand side of 0, if we see here, we have 0 and then the number towards the left of 0 is -1. And the more you go towards bigger numbers, okay, so to say bigger numbers, okay, but with negative signs, what happens is your number becomes smaller and smaller. That means 0 is bigger than -1. So the number to the left is -1. So -1 is smaller than 0. Similarly, if I compare these two numbers, okay, -2 is smaller than -1 because you are going away from 0. Okay, then if I take these two numbers, so -3 is smaller than -2. Okay, and this will keep on going. Similarly, what we had seen this on this side some time back was what? 0 was smaller than 1. 1 was smaller than 2. And 2 is smaller than 3. And if you see, 0 is on the left of 1. You see, 1 is on the left side of 2. 2 is on the left side of 3. Correct now? That means what it said here, that for any pair of numbers on a number line, the number to the left is smaller than the other. This is the explanation for that. Okay? Then they say that also, if the numerator and the denominator, suppose if I write a fraction a upon b, for example, right now, this is rational number, fraction, this is numerator, this is denominator. So, if the numerator and the denominator of a rational number, such as a upon b, is multiplied by any non-zero number, okay, so I have assumed here that the number is k, which is non-zero number, okay, so if I multiply this by that non-zero number k and k, so this gives me ak or ka upon kb, right? And what happens is, then the value of the rational number does not change. Okay, that means what? The value does not change. So whatever is this a upon b, whatever fraction has been given to us, okay, whatever fraction has been given to us, the value of that fraction will not change when we multiply this numerator and denominator by a non-zero number. Okay, chalo. Then such that means it remains the same, that is a upon b is equal to k upon kb, where k is not equal to 0. Okay, so I hope this is understood, and this part we are going to use in our upcoming solved examples. Alright, okay, I hope this one is understood. Now, having been understood this part, let us see our first solved example. The question is something like this. Compare the numbers 5 upon 4 and 2 upon 3. Write using the proper symbol of less than or equal to or greater than. Correct ना? So, ये दो जो numbers जो हैं, fractions जो हमारे पास है, rational numbers, okay, ये इनमें छोटा कौन है, बड़ा कौन है, क्या equal है कि नहीं? This is what they are asking us basically. Okay, so what we will do first? So first I will write this 5 upon 4 is equal to something. My second fraction is 2 upon 3 is equal to something is going to come here. Now what I will do is, if you see carefully, the denominators of both the rational numbers are not the same. Correct, na? So I will try to make this denominator same. So once I make the denominator same, what will happen is I will just compare the numerators and will decide that which one is bigger or which one is smaller accordingly. Right? Come on. So let's do it. So what I will do, this 5 upon 4 I will write as it is, and I need something to multiply over here. Right? No? Like how we multiplied k on this side, the same thing we are going to do on this side as well. So what I will do, I will take the denominator of my second fraction. My second fraction is 2 upon 3. So the denominator over here is 3. So I will take this 3 and put it here. Alright. So this will give me 5 3s are 15 upon 4 3s are 12. Okay. So when I reach here, this means that my 15 upon 12 is equivalent to 5 upon 4. Okay. Now let us try with this one. We have 2 upon 3. Okay. So I will write this 2 upon 3 as it is. And now I need some value on this side. That is the word k again. Correct now? So now what we did here, when you were trying to tackle this part, okay, we took the denominator of the second fraction. Now since we are working on second fraction, we will take the denominator of the first fraction. So first fraction is this one and denominator is 4. So I will take 4 over here. Alright. So this will give me 2 4s are 8 upon 3 4s are 12. Okay. So now what we have, okay. So now we have 15 upon 12 and 8 upon 12. Correct, na? Okay. We have these two. Therefore, 15 upon 12 and 8 upon 12 are the equivalent fractions of the given rational numbers. Okay, right? Denominators, we can see denominators of both the fractions so obtained are same or equal. Therefore, comparing numerators, we get what? 15 and 8. Correct? So 15 is greater than 8 or bigger than 8. Correct? Now this 15 I got from this. That is 15. That is 15 upon 12, and this 8 I got from here. okay, is greater than 8 upon 12. Okay, therefore, now 15 upon 12 is equivalent of which one? This fraction. Therefore, 5 upon 4 is greater than 8 upon 12, and 8 upon 12 is the equivalent fraction of 2 upon 3. So I will write 2 upon 3 on this side, and here my solution is done. Okay children, I hope that it was very easy and you enjoyed as well. Okay, so if you think that you are enjoying and you are learning maths with me, you are gaining confidence, so it's a humble request to please do like, share and subscribe my channel. Okay, I will come up with these type of videos every now and then. Basically I upload one video, at least one video almost every day. Okay, and your likes, your comments and your subscriptions, they keep me motivated. Okay, and that's all. I love you all and see you soon in my next video. Till then, bye bye.